Hey everyone, today I'll go over a medium problem on Leetcode 138, copy list with random pointer. So basically we're given some linked list. We have a lot of stuff here, but I'm just going to explain it as simple as possible. We're given some linked list that kind of like looks like this. It's a normal linked list, meaning that it has a value, it has a next, but it's modified so that it has some random attribute. Random is just like next, except it's not sequential. It points to some random other node in this list. So it makes things more challenging. And the objective here is that we're supposed to return a clone of this linked list. So if this didn't have the random, we could actually do this fairly simple. We could just traverse the linked list and then like create new nodes for each node we see and like copy the value over and then return that. The problem is with this random, it makes things actually quite complicated, and you'll see what we run into in a second. So a way I'm going to solve this, or explain to solve this, is I actually want to try to solve it how you would think to do it naively. So you might think to like have like some result node, basically, like you could have like a head here, and you could basically, or you could have a head here, and basically like set it to 0 like a dummy, and then basically you could have like some dummy point to head, and then you could return head.next, and then you could essentially like go through the list, right? So, or actually we don't really want to call this head, let's call this dummy head, and let's call this node dummy, and we would actually return dummy head.next. And you might actually go ahead and just go while head is not equal to null, traverse through it, head equals head.next, and then like maybe you would go like dummy.next is equal to a new node, you copy the value over, and then you would do like dummy.next dot random is equal to head.random, something like that. The problem is with this, or like clone it or something. The problem is with this approach, and I'm not even going to continue, is if you get to another random in the list, you actually have to have a reference of that random's next and random. So the problem is you can actually like clone this like you would do here. The problem is we would get to that random node later in the list, the one that it points to, and it wouldn't actually have a reference to the true next and random of that random node. Now that was a really butchered explanation, but I just kind of wanted to go through like what you might think of doing like naively. And there's a reason why this is medium, is you kind of have to think outside of the box. So we need a way to map every single node in this list to some cloned node. So we need to walk through the list and just make clones first. And when I say map original to clone, yeah, that's exactly what we're going to do. We're going to map. So let's have a map of a node to another node. So basically, it's going to be original map to clone. And we're just going to call this map and make it a new hash map. And then what we want to do is let's have a cur and set it to head. The reason being is we actually want to iterate through this twice. So we're going to create a reference to head. So while cur is not equal to null, let's go ahead and just map it, right? So let's just put in our map the current node and map it to a new node we create out of it. So we can actually go through and do new node, right? And just clone the value. So a fresh node, a fresh clone node with the same exact value as cur. And the next thing we want to do is move cur forward. So just cur equals cur.next. Okay, that's all good. Lastly, what we want to do, or actually before we do the loop, we got to think, what are we trying to do? What are we trying to accomplish? Well, at the end, the desired effect would be, since this is mapping original node to clone node, the desired effect would be we could just return map.getHead, right? Because at the head, whatever's in our map should have the cloned node of that head, and that'll have the whole entire linked list because it's the head. So that's what we want to get to eventually. And you might think, why isn't this good? Well, the problem is if you look here, we just made like empty clones and we didn't really populate any next or random. So we have to go through back one more time and populate the next and random. So let's reset occur back to head, and let's do the same thing that we did before. Go through, loop back through. And then now what we want to do is fill the next and random. So we know they're all in the map at this point. So we can do map.get cur, so get the current node. So basically this is getting the clone of the current node, and we have to set the next and the random. So what does the next equal to? So you have to think about this for a second, right? Because we want this current node's next, but we want the current node's next's clone. So how do we find that? Well, it's in the map. Remember, we mapped all original nodes to its clones. So all we do is map.get cur.next, so we're getting the clone of next, and then that's that. It's that simple, right? And we just copy this down, and you literally do the same for random, right? No difference. They're just two different types of pointers. And then as normal, we move cur forward. So this is what we're going for here, and you're probably thinking, oh, why didn't we just do this all in one loop? This makes no sense. Well, you do it this way because we have to actually map all the original nodes to its clone nodes first. Because you might get a null pointer exception when you're trying to reference a random that doesn't exist in the map yet. So it's just like you do this first, you fill up, you map all originals to their clones, then you go back through, then you do the next and the random. And let's run this. It's actually going to have like a null pointer exception or something. Or actually, this looks pretty good. Let's submit this. It probably will get a null pointer exception. Oh, actually, this is pretty good. That surprised me. I thought that when it got to the null and it tried to do next to random at the end. But yeah, 100%, 70%. So this is pretty good. Let's talk about time and space. Time is very simple. It's just on, because we just really have two while loops that are going through every node in the list. Even though there's random pointers and it might have a cycle, it doesn't matter. We're just going through the list twice. So it's 2n or n. Space is also on because we use our map and we have to map every single node in the list. So we have to store every single node in the list. So it's going to be on space as well. So yeah, hopefully I made this problem that was kind of confusing just a little bit simpler. Thank you for watching, and feel free to subscribe. Thank you.